Hello, my name is Tyler Rutland. In this presentation today, I will cover an article written by Meyer and others on music exposure and how it affects the auditory system in children. We will discuss the hypothesis proposed by the authors, methods and materials used, discuss the results and the findings of the study, and finally, I will end with some future research. Musical training has been associated with enhanced auditory processing abilities, particularly in children. Recent studies using neurophysiological techniques demonstrate that musicians exhibit superior preattentive auditory processing compared to non musicians. Preattentive meaning subconscious, so it just happens kind of naturally. This is believed to stem from the neuroplastic changes induced by extensive musical training, which can enhance the brain's ability to detect differences in sound. This study aims to investigate the impact of early musical training, specifically through the Suzuki method, on the auditory nervous system of children. To do this, authors used a behavioral pitch recognition test and EEG recording and analysis. The Suzuki method of music education emphasizes learning music by ear, similar to language acquisition, and typically begins at a young age. This approach puts a strong emphasis on auditory skills over visual notation, as traditional music lessons do. A key component to this method is having an early start. This early exposure is believed to foster a natural and intuitive understanding of music. I'm going to go back to where it says emphasis on auditory features. So this is especially important in the discrimination and recognition of pitch and timbre. So pitch is how high or low a sound is. So this is fundamental for identifying notes and melodies. This also plays a role in the harmonies of music in certain notes. Timbre can be described as the color or texture of a sound. So this distinguishes different types of sound production, or it can be described as the uniqueness of a sound. For example, two people can sing the same note, but it will sound different because of timbre. Or for an example, a note that is the note C on a trumpet and the note C on a piano will sound very different because of this as well. I'm going to make a special call out to that because it will come up later in the study. The hypothesis of the study is that musical training, particularly through those Suzuki violin lessons, enhances the auditory system's sensitivity to acoustic variations in children. Researchers aim to investigate how the intensity and duration of musical training affect preattentive auditory processing. So authors had believed that brain responses to complex sounds in Suzuki students were expected to differ more strongly in the violin condition regular to the pure tone condition, and brain responses to complex sounds in untrained children were expected not to show any considerable differences. This was measured by the mismatched negativity response to various stimuli, or in other words, it was just the brain's ability to automatically detect changes in auditory stimuli without focused attention. Again, this study suggests that children who participate in extensive musical training will demonstrate stronger responses to their deviant acoustic cues compared to their peers without musical training. Now I'm going to get into some of the methods and materials used in this study, and also later we'll dive into some procedures, but I want to start here with the participants. So there were 18 students from the Suzuki Music School. 9 were male and 9 were female. These students had a mean age of 10 years with a standard deviation of plus or minus 1.61 years. They began violin training at approximately 5 years of age and practiced between 90 and 485 minutes weekly. These students had attended an average of 5 years of Suzuki Music School. The controlled children, there were 19 controlled children, 9 male and 9 female. These children had a mean age of 9.78 years with a standard deviation of plus or minus 1.62 years. 4 children had undergone instrumental education, but they began much, much later than those students from the Suzuki Music School. Their practice time per week was also much shorter. The length of the practice time had an average of about 75.2 minutes with a standard deviation of plus or minus 17.08 minutes. And also, none of these children played violin as compared to those from the Suzuki Music School. I'm going to call out another important fact is that these participants were native Swiss German speakers. Some did grow up speaking a second language, which was English or French, but the majority of those students were Swiss German speakers. One control subject ended up being excluded to a data loss. So a MMN procedure was used to present the different auditory stimuli. So MMN stands for mismatch negativity, which is an electrophysiological response that occurs in the brain when it detects a deviation from a regular auditory pattern during active listening. So it reflects the brain's ability to detect changes in auditory stimuli without focused attention. So those presented two different auditory stimuli, which were standard tones and deviant tones. So standard tones were those sine wave tones or pure tones, and violin tones, which were complex tones. Pure tones are sound waves that consist of a single frequency, which produce more clear and distinct sounds. Complex tones contain multiple frequencies. Deviant tones are variations of the standard tones that differ in intensity, frequency, and duration. Electrophysiological equipment, or EEG, so electroencephalography, was used to record brain activity. A portable EEG system was used to measure the MMN response, which reflects pre-attentive auditory processing. So that's just that subconscious auditory processing that was going on in the brain. The pitch recognition test was a behavioral test designed to assess the children's ability to recognize and identify specific pitches played on the violin. So now we will get into the procedure of this study. So first we will start with the EEG recording and analysis. So participants were fitted with a portable EEG system. The electrodes were placed in accordance with the International 1020 system to ensure consistency across participants. Participants were placed 120 centimeters from a monitor and then instructed to watch a silent cartoon. The participants were instructed to focus on the film while ignoring the auditory presentation of the stimuli. The auditory stimuli consisted of standard tones, which were the sine wave and the violin tones, and deviant tones that varied in features such as intensity, frequency, and duration. EEG data was continuously recorded during the presentation of the auditory stimuli. The recording captured the brain's electrical responses to both standard and deviant tones. Before that data could be analyzed, it underwent pre-processing steps which filtered out any background noise and artifacts, so only relevant brain activity was analyzed. The next step was to remove any eye movement or muscle artifacts to ensure the integrity of the data and avoid confounding results. The analysis here focused on those MMN responses, or mismatched negativity responses. The MMN is typically triggered when a tone that differs in frequency or intensity is presented among a series of standard stimuli. The data was then segmented, and researchers conducted statistical analyses to compare the response between the two groups. Also, participants participated in that behavioral pitch recognition test. So the behavioral pitch recognition test utilized 72 violin sounds covering a range of pitches from 2 different octaves. Each sound was presented 3 times in both octaves. Pitch range began with the lowest violin tone and covered all tones within that octave. Many music lessons in the first 5 years of training use this method, which is why this method was selected for this test. The violin tones were presented in a pseudo-randomized order to prevent any predictable patterns that could influence the participants' responses. Before the test began, participants received oral instructions from the investigator. They were informed about the task and what was expected of them during the test. Participants were required to identify each tone by naming it according to the German notation system. This is important to note because, as I mentioned earlier, these participants were Swiss German native speaking, so that's just an important call out to make here. This involved indicating the specific pitch they heard and identifying the note name. Responses were recorded by one of the authors to ensure accurate data. Next, we'll go to where this data was analyzed. Independent analyses were conducted to evaluate the participants' performance on the behavioral pitch recognition test. The results indicated considerable inter-individual variation in pitch recognition performance. However, the analysis that tolerated semitone errors showed high hit rates among the Suzuki students. Specific tones, such as G, D, E, and A, were all recognized significantly better than other tones by Suzuki students. This is likely due to the relevance for violinists and their ability to be played as open strings. A Spearman correlation analysis was also performed to further explore the relationship between pitch recognition and performance. A significant positive correlation was found between the intensity of training and the pitch recognition hit rate. This indicated that more practice was associated with better pitch recognition performance. In the EEG recording and analysis, Suzuki students exhibited enhanced MMN-related area values in response to deviant violin tones compared to controlled children, which indicated that musical training does influence auditory processing. Earlier, I mentioned the concept of timbre. Timbre is the uniqueness of sound. Significant interactions were found between timbre and group as well as deviant in timbre. So Suzuki students process violin tones differently than the control group, showing a more pronounced MMN response to those tones. This makes sense because these students are violin trained, and therefore their brains are able to differentiate violin sounds from other instruments because they are more familiar with those violin sounds. So what do these results of the study mean? The first thing to consider is the relationship between musical training and auditory skills. The study reinforces the idea that musical training, particularly through methods like the Suzuki method, significantly enhance auditory skills and training. This supports previous research suggesting that intensive musical training can lead to improved pitch recognition and auditory discrimination abilities. The results highlighted that Suzuki students showed significantly better recognition of certain tones. This suggests that the type of instrument and the nature of training can influence the development of auditory skills. Another concept to consider is that of neuroplasticity. This suggests that musical training induces changes in the auditory system. The enhanced MMN responses observed in Suzuki students indicate that their brains are more adept at processing musical stimuli, reflecting the impact of early and sustained musical training on auditory processing pathways. In this study, there will always be some limitations to consider and also future research that can be done. The first here is variability in age and developmental stage. Age variability can introduce developmental differences that affect auditory processing. Younger children may not have fully developed auditory skills compared to their older peers. Next is sample size. This is a relatively small sample size and could limit the generalizability of results. So a larger sample could be produced, and that would guarantee more diverse results. Training intensity. So while the study did account for the intensity of training in minutes per week, it did not account for the quality of practice, which could become a confounding variable. So there might be some students who are in more intense training. They're more complex music pieces that they may study, and this is something that should be considered. So for the future, Future research should consider longitudinal designs to track the development of auditory skills over time in children. This will help clarify the long-term effects of early music education. Also, studies comparing different music education methods could shed light on which aspects of training are most beneficial for auditory skill development. So, not just violin training, but it could be piano training. We could see how, piano sounds affect auditory training as well. That is all I have for today. Thank you so much for listening.